Hello! In this video, we are continuing a previous example where we are finding the volume obtained when the curve f of x equals x squared is revolved around the line y equals -3, and we'll do this as x goes from 0 to 2. So we recall the first step in these volume of revolution problems. The first step is really to graph the function, and so we've plotted the curve y equals x squared, and this is the parabola, and we're looking at the piece of the parabola as x goes from 0 to 2. Now, before we actually calculate the volume, I'd like to draw a picture of what this 3D solid is going to look like. So now we're reminded that we're revolving around the line y equals -3. And so if we come down 3 units here, so here is the line y equals -3. And so this is the line around which we're revolving. This is supposed to be a straight line. And so I'm just going to draw a little arrow here to remind us that this is the line around which we're revolving. Now, we're going to take our curve, which is f of x equals x squared, and we're going to flip it over this line of revolution. So notice that there are 3 units above, so I need to go 3 units below. And so my parabola is going to be reflected roughly looking like this. And if we connect the outer edges, kind of try to add a 3D perspective here and bow this edge out a little, and this edge goes back into the page a bit. And then I can add some edges to this to give the 3D perspective. When we revolve this around, we end up with an object that's not quite like a bugle. Remember, our bugle came to a very fine point in the previous exercise, but in this exercise we end up with this shape. Maybe it looks like a hat, if you'd like to think of it that way. Now, we can go back into Maple and ask Maple to draw this figure for us. Just to recap, we have previously looked at the same curve revolving around the x-axis. That was example 1. And then we did the same curve revolved around the y-axis. That was example 2. And now, oops, excuse me, Maple's getting a little bit carried away here. Just go down and grab that. I just want to copy and paste this code. You can also access the volume tutor by going up to the menu at the top of the screen. So we're going to use our curve x squared, and we're still going from 0 to 2. We have a horizontal line of revolution, although this time we're going down 3 units. And there's the curve. This is exactly what we drew on the other page there, and we can plot that here. Now, to calculate the volume, I'd like to hop back over here and draw a representative disk. So the disk that I'm going to draw, remember that the height of the disk is parallel to the axis of revolution, and here's the front edge of the disk, and back up the back side. So there's a little disk, and here's the center of the disk right on that axis of revolution. And if I exaggerate this a little bit here, and I think about a cylinder maybe tipped on its side, there's the sideways cylinder, there's the center, and when I think about the radius goes from that center point up to the outer edge, and that radius, we need to be very careful with how we calculate the radius here. So that radius, the center is going to start at that line of revolution, and it's going to go all the way up to where I hit the function f of x. So that radius is going to be 3 units plus however far it takes me to get up to that red parabola. So that's going to be 3 plus x squared. Another way of thinking about that is x squared minus a minus 3. It's the same radius that you'll end up with, just a different way of thinking about it. And then the height of this cylinder, or the thickness there, that's going to be my dx. So let's label that height equals dx. Okay, let's hop back over to Maple and going to come down a little bit here and put this up at the top of the screen so we can see what we're typing. So we're reminded that volume equals pi r squared times height. And in this case, we have volume and we have pi. That's not going to change. Our radius, let's recall, that was 3 plus x squared. And we have to square that because our formula for the volume of a cylinder says that we have to square the radius. And then that's all times the height, which in this case, where the thickness was dx. And so what we want to do is we want to sum up all of the volumes of those little tiny slices of those little tiny discs, and we're going 0 to 2. And now let's just copy that formula all in there. Now, before I actually go in here and try to figure out what this integral is, let's FOIL this 3 plus x squared out. Let's actually multiply that out. I'm just going to do a little quick copy and pasting here, save time typing. And so what are we going to get when we actually multiply out what we have? In the integrand, we're going to have pi times 9 plus 6x squared plus x to the 4th, close the parentheses, dx. And we could continue on and figure out, we could do the antiderivative of each piece and work the problem from there. So we'll just scoot up a little bit there and finish out the problem. Actually, we'll just do the antiderivative right here. So we'll have the pi out in front, and then we'll have 9x plus 6 over 3 x cubed plus 1 over 5 x to the 5th, and that's all evaluated as x goes from 0 to 2. The rest of the problem from this point is arithmetic, and you can finish it from there. Let's go back up to compare what we have with what Maple is doing here in the volume of Revolution Tutor. So we'll go back in here and set up the x squared. We have 0 to 2. That looks good. We have a horizontal axis of revolution around the line y equals -3. There's the same integral that we set up ourselves, and there is the exact answer as well as the decimal approximation.